All right, let's solve some of these problems. So let me get a pen here. So the first one says express the indicated degree of likelihood as a probability. So a probability is a number between 0 and 1. So it's going to have decimals. You have a 50-50 chance, that's 50% chance. 0.5. You cannot determine the exact decimal number value of pi. That is true. So the probability of determining that value is going to be 0 because you cannot determine it. So that will be A. I will definitely, it will definitely turn dark tonight, so the probability of that is 1. That is for sure. So that will be D. You have 1 chance in 10 of winning the race. That's 1 divided by 10. And 1 divided by 10 is 0.1. And which of the followings cannot be a probability? A probability cannot be negative. So that's that. Those are the first 5 questions. What is the probability that an event that is certain to occur? Well, if it is for certain, it will always happen, so the probability of that would be 1. A sample space consists of 154 separate events that are equally likely. What is the probability of each? Because they are equally likely, so the probability is 1 divided by 154. So that would be A. If a person is randomly selected, find the probability that his or her birthday is in May. Ignore leap years. Well, there are 12 months in the year. You're assuming that May is one of those months, so that would be 1 out of 12. Let me see. Well, um, actually, what happened right here is just pay a little bit of attention to this problem number 8, because in reality we have the whole year, and the year is made up of days. So we have from January 1st to this, which is 300 and let's say 65 days. And May is a number of days within this year, so my birthday could happen any place in there. Let's say 31 years. So this is a chance it can happen in these 31 spots out of what? Out of 366 different outcomes. So the answer is C. Alright. So a bag contains 2 red marbles. Let's look at this one right here. Let me erase this. So a bag contains 2 red marbles. So we have a bag and we have 2 reds, 3 blues, and 7 greens. So we have green, 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 and then 3 more greens. Right. If a marble is randomly selected from the bag, what is the probability that it is blue? Well, how many blue do we have? 7. How many marbles we have in total? That will be 12, or 1 divided by 4. So I think the answer may be D. Okay? All we're counting is the total number of marbles. That will be the sample space that always goes in the denominator, and the number of marbles that meet the characteristic, in this case that they're blue. Right? So that's 9. That was 9, so we got that. Okay. So in problem number 10 it says refer to the table of the result of testing for a certain disease. Positive test results, we got this. Negative test results, subject has the disease, the subject doesn't have the disease. So we need to positive test, negative test. Subject has the disease, subject is positive, subject doesn't have the disease, negative. 87, 6, 27, 158. It's always a good idea to find the totals. So this will be 87 plus 6 will be 93. That is the number of subjects that have the disease. 27 plus 158, that gives me 185. That's the number of subjects that do not have the disease. Alright, and also I want these totals right here. That will be 27. 87 plus 27, 114, and now 6 plus 158, that gives me 164. These numbers need to add up to the same value. Let me just check that. So 114 plus 164 gives me 278, and 93 plus 185 gives me 278. So that's correct. That's the total, that's the sample space. That's why we needed to do that. Alright, now the question says if one of the results is randomly selected, what is the probability that it is a false positive? False positive. So this indicates that the person has the disease when in fact they don't. So that will be this 158 people. False positive. Oh no, that is wrong. That is not those people, because the test indicates that they have the disease when they don't have the disease. So that would be these 27 people right here. Test indicates that they have the disease, but they don't have the disease. So the answer would be 27 divided by 278. And that gives me 27 divided by 278 equals 2.097. 0.097. So that would be C. Right. So if you're going to have any problems with these questions, might be understanding what is a false positive. Alright, this is the next one. Number 10. Number 11. Answer the question, consider an event to be unusual if it is no less than equal to 0. So an unusual event is one where the probability is less or equal to 0.05. So it is unusual to get 12 when a pair of dice is rolled. Alright, so when we roll a pair of dice, to get a 12, it means to get the sum of 12. We do this right here. So this is what happens when I roll the dice. One of the dice, let's say the blue one, the outcome of the blue die, say, could be a 1, a 2, a 3, 4, 5, or 6. 1, 2, 3, 4, 5, 6. So the outcome of the red die. Alright, so since we have two dice, the blue one could be a 1, 2, 3, 4, 5, 6, and the red one could be a 1, 2, 3, 4, 5, 6. We're calculating the sum. When we add what came out in the blue die and the red die, a 1 and a 1 gives me a sum of 2. A 1 and a 2 gives me a sum of 3, 4, 5, 6, 7. This 7 is that I got 1 in the red and 6 in the blue. When I get 2 in the red and 1 in the blue, the sum is 3, and so on. We can actually calculate all these sums. 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10. 5 and 1 is 6, 7, 8, 9, 10, 11. And then 6 and 1, 7, 8, 9, 10, 11, and 12. So those are all the possible sums when I flip two dice. Now, how many simple events do we have? How many possible sums do we have? by counting this, we get 36. So that's the sample space. How many of those sums are 12s? Only one, which is this one right here. Only one. Okay. So now, the probability is going to be 1 out of 36. If I divide these numbers, 1 divided by 36, then I get 0.27, 0.027, and that's less than 0.05. That's less than 0.05. Therefore, yes, the event is unusual. Based on this definition given here. By the way, what is the probability of getting 7? What is the probability of getting a 7 when I roll a pair of dice? So in this case, again, the sample space is still 36. And then how many 7s do we have? 1, 2, 3, 4, 5, 6. That would be 6 out of 36, which is 1/6. And there is a game in which you have to get a 7 or 11. So the probability of that is going to be 8, because 7 or 11. So 6 plus 2 11s, 8 out of 36. Alright, so the answer to problem 11 is 8. So let me erase this 10. That way we can do the next problems. So in problem number 12, it says flip a coin 3 times and find the sample space. We have done this many times. We need 8. 1, 2, 3, 4, 5. So this is not the answer. 1, 2, 3, 4, 5, 6, 7. That is not the answer, because we know that the outcomes by the multiplication rule is 2 outcomes for the first coin, 2 for the second, 2 for the third. So we have 8 simple events. So now the answer is A or D. H H T H T H H T T T H T H T. So the answer is A. A is okay. 1, 2, 3, 4, 5, 6, 7, 8. Why this is not the answer? Alright, so this one is repeated. So that is not the answer, because there is one simple event that is repeated, and because you have 8, so there is one missing. Alright? So now question number 13 says that Frisky is having her 5th litter. The probabilities have either been 3 normal pups and 2 normal pups and a runt. So the probability of the outcome is 50%. So what is the question? Frisky is having her 5th litter. The prior litters have either been 3 normal pumps or 2 normal and 1 runt. Oh, the one, the sample space. I'm sorry, I didn't. The question is right here at the top. So I'm like reading that, and what is the question? The question right here is to create the sample space. So the only thing that we know is that the outcomes of observing what Frisky have done in the past is either 3 normals, so that would be N, N, N. That's what we have observed. 2 normals and a runt, so that would be N, N, R. So basically that's what it is. This is the answer to this problem. Remember that an experiment is observing outcomes, right? We could have observed this 20 times. In other words, this Frisky could have 20 liters, however you pronounce that. But in all of those, the observation has been always either 3 normals or 2 normals and a runt. So that is the only observation. So the answer to this problem is C. Even though the experiment has been performed 5 times, the outcomes of the experiment have only been 2 possibilities, right? Alright, let's look at this problem 14. and we said that both Fred and Ed have a bag of candy containing a lemon drop. Both Fred and Ed have one bag of candy containing a lemon drop. Alright, so let's see what we have right here. Okay, so these kids have a bag of candy. Let's do a table. Well, let's do many tables, because what is going to happen right here is this. This is Fred and this is Ed. So Fred, what is in these bags? In these bags they have a lemon drop LD, a cherry drop CD, and a lollipop LP. Okay, so what could happen is that Fred gets this LD, and also Ed get the LD from his bag. There are two bags. Or Fred gets the LD and Ed gets the CD, LD, and LP. So those are the possibilities right there. When Fred gets the LD, then Ed could get any one of those three. The same thing happens for the when Fred get out the CD first. Then Ed could get the LD, the CD, or the LP. And finally, when Fred pulls from the bag the lollipop, then Ed could drop the lollipop again, or maybe the lemon drop, or maybe the CD. What is that again? Whatever that was, cherry drop. Right? So that's the sample space. Those 9 simple events form the sample space. So the only thing is that we need to find, well, it's definitely not this one. We have to have 9 combinations, and the combinations are written like this: LD, 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 CD, LD, LP, like that. Right? And we have 9 of these. So we need to have 3 that begins with LD. LD, LD. Cannot see very clear. LD right here. So those are the 3 with LD that begins with LD. So anyways, let me move on, because what you need to do here, this is not the answer. You need to find one answer that has the right combinations. It's probably C, but I let you look for it. Some of these are going to be repeated, so since we have to do so many problems, I'm not going to do that. But the important part right here is generating the sample space. Alright, let's see what we have here. It says 2 white mice mate. The male has white and black. So the best thing is to do a cross tabulation. The male, white and black. The female has only white, so the female genes can be white and white. So in the combination right here, it could be that you get white and white. Right here you're going to get black and white. Right here you're going to get white and white, and right here you're going to get black and white. So the only possibilities are these, that either you get white white or white black, and that is D. That's a sample space. Alright, if an apple is hanging from a string and 3 flies land on it, find the probability that all 3 are on points within the hemisphere. Alright, so let's do this different ways. But one possibility would be that we have 3 flies, fly 1, fly 2, fly 3, and they all land in the south, south, south. Maybe this one lands south, south, and this lands in the north hemisphere, and like that. So we know how to generate the sample space again. So alright. So basically what we're saying right here is that the 3 of them land in the south hemisphere. The first 2 land in the south, but the last one in the north. First one in the south, north, south, and so on. And the question is, what is the all 3 land in the same hemisphere? So this simple event right here, they all land in the south, and this simple event right here, they all land in the north. That's 2 simple events out of 8, or 1 out of 4. That's 0.25. So that's A. Definitely this is not the answer. Our probability is going to be less than between 0 and 1. So you can eliminate one of the answers just in case you have to guess. So you have these 3. Another way of doing this problem is this. so you have the 3. Basically it's the probability of the 3 flies landing in the same place. So the probability that the first fly lands someplace is 1. This is the probability that the first fly lands either in the north or south hemisphere. Once the first fly is there, the probability that the second fly will land in the same place is going to be 1/2 times the probability that the third fly will land in the same place is also 1/2, because you have to choose between 2 hemispheres, and that will give you 1/4. This method right here is using the multiplication rule, right? Okay. Spinner has equal regions, numbers 1 through 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Alright. What is the probability that the spinner will stop on an even number? So let's guess the even numbers. These are the even numbers. So those are counted. Or a multiple of 3. A number that is divisible by 3. Let's count those. An even number or a multiple of 3. This is a multiple of 3. Even though it's odd, it's a multiple of 3. Right, we need know that, but we need that. Alright, this is a multiple of 3. 5 is not a multiple of 3. 7 is not a multiple of 3. 9 is a multiple of 3. 11 is not a multiple of 3. 13 is not, and 15 is. Alright? So in total we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities out of 15 possibilities. And that should be divide this by 5, so that would be 2 out of 3. So that would be the answer in question 17. Alright, so a spinner has equal regions, number 1 to 15. Oh, we did this already. We just copy it again. So let's see what this is. The table describes the smoking habits of a group of asthma sufferers. If one of 10, 14 people is randomly selected, find the probability that the person is a man or a heavy smoker. Alright, so find the probability that the person is a man. So we have all these people are males. All these guys, we need to count them. 533. We need to count these 533 because they're males. So we have 533. plus it's an or, so that's why it's plus. Find the product percent male or, so that's why it's plus. Heavy smoker. Heavy smoker are these people. So I need to count all these people without counting this 42 twice. Because I already counted this 42, all I need to do is this other 47 smokers that are no males but are heavy smokers, so that would be 47. When I add those two numbers, 533 plus 47, I get 580. So that the answer will be 580 divided by the total, which is 1064, right? And that is 580 divided by 1064. Oh my god, what am I doing? 580 divided by 1064.55. 0.45. I think this is it. Alright. We get that. Alright, so let's see what we have right here. It says that a sample of 100 wood and 100 graphite tennis rackets are taken from a warehouse. So how many we took in total? That would be 200. 200 tennis rackets. They have two characteristics. If 9 wood and 9 graphite are defective and one racket is selected at random, what is the probability that the racket is wood or defective? So the probability that the racket is wood or defective using the addition rule is the probability that is made of wood plus the probability that is defective minus the probability that is made of wood and is defective, right? So what is the probability that is made of wood? Well, we have 100 wood rackets out of how many total rackets? 200. So what is the probability that is defective? We have 9 wood and 19 graphite defective. That would be 28 out of 200 that are defective, minus the probability that is made of wood and is defective. Probability that is made of wood and is defective is 9 out of 200. So that should be the answer to this problem. Common denominator 200, the numerator is 119. So 119 divided by 200 gives me 0.595 B. Alright, I hope that's the answer. Alright, so a study of consumer smoking habits includes 162 people in the ages of 18 to 22, 67 of whom smoke. Okay, so this is calling for doing a table. I think is better here. So basically what this is saying is you have 162 people from 18 to 22. So 18 to 22, the total number of people is 162. Smoke, not smoke. And then it's saying that 57 smoke. 57 smoke. So how many don't smoke? 162 minus 57. 105. I don't know if we need this information, but we put it here. Alright, then it says that we have 120 people from 23 to 30. We have 127 people and 37 whom smoke. All right. 90 tons. And the last thing, we have 85 people from 31 to 40, 85 people, and 20 who smoke. So that gives me 65 ton smoke. All right, so we have the totals. We could add how many smokers we have and so on. So let's see what the question is. It says if a person is randomly selected from this sample, find the probability of getting someone who is aged 23 to 30. So we just highlight those. 23 to 30 are these people, right? Or smokes. So smokes, we need to add these people because they smoke. So we have everyone who meets the characteristic. We need to add them because they are. And so that's the answer to this problem. And we need to divide by the total number of people. So we need to find this total right here. That's important to finish this table. How many people we have in totals? 162 plus 127 plus 85. That gives me 374 individuals who were surveyed. Of those, we have 57 plus 37 plus 20 plus 90 divided by 374. That gives me 0.54 or 0.45. 0.45, I'm sorry. C. Alright. Now what you need to keep in mind is this. So it's or. When do you multiply? Like for example, if they tell you what is the probability that we take two people at random and both of them are smokers. So what is the probability that if we take two people at random, both of them are smokers? So once you say both, it's not an or because to take two people, you need to take the first one first and the second one. And you want both of them to be smokers. So basically you want the probability of a smoker, two smokers. And for that you need to use the multiplication rule, which is the probability of having a smoker and then a smoker is the probability of having the first smoker and then a second smoker given that the first person was a smoker. So in this case, this will be how many smokers do we have? We have 57 plus 37 plus 20. We got 114. So we have 114 smokers right here. So it's going to be 114 out of 374 times a second smoker will be 113. We already pulled one out. 373. Alright, so I just wanted to make sure that it's clear because for sure this will be an option in your assessments in which you use the addition rule for or and when do you use the multiplication rule. Alright, so the manager of a bank records the amount of time that each customer spends waiting online during a peak business hours on Monday. The frequency table below summarizes the results. So what is the question? I don't know what the question is here. Alright, so I need to go and find the question because I didn't have it. So it says if we randomly select one of the customers represented in the table, what is the probability that the waiting time is at least 12 minutes? At least 12. So that means 12 or more. That's all these people. At least 12 minutes. This is how many we have. Or between 8 and 15. Between 8 and 15, that will be this crowd right here, between 8 and 15. Alright? So, if we count how many of these customers fit the characteristic, is all these things right here, it would be 12, 20, we don't count the 8 twice, 20, 24, 27, 29. Out of how many customers? We need to count the customers. We need to add these numbers. 11 plus 14 plus 12 plus 8 plus 4 plus 3 plus 2, 54. And now we divide 29 divided by 54, and I get 0.537. Okay, there is an answer that looks like that, 0.537. Alright. Let's see what this is. That's another one that I cannot see the question. Let me see if I can make this smaller. Oh, the question is right there. Alright, so let's make this smaller so I can see what they're asking. Alright. So we have 100 people, employees of a company. Oh, you probably cannot see even the question because it's outside the graph. Let me see if the last question was outside. No, this is okay. It's this one that. Okay. So now 100 employees of a company are asked how they get to work and whether they work full-time or part-time. And so we have these results. Section 1 represents public transportation. We can even do a little table here, just in case we need it. Let's do a little table. So basically we have transportation, and right here then full-time, part-time, full-time, part-time. So public transportation, we have public transportation, we have 7 full-time, we have 8 part-time, so we have 15 people who use a public transportation. Bicycle, we have 4 full-time, 5 part-time, for a total of 9 people who use bicycles. Driving alone, we have 35 full-time and we have 25 part-time, for a total of 60 people who like to drive alone. And then carpool, we have 8 full-time and 8 part-time, for a total of 16 people. These numbers need to add up to 100. Let's check to see if we did the table right. So we have 15 plus 9 plus 60 plus 16, 100. So that's right. Alright. We can even count the number of full people just in case we need that, and the number of part-time people. But what is the question? The question is find the probability that someone who carpools, or, so we need to add, and it says carpool. What is carpool? Right here. These people are the one who carpool, these 8 people, or someone who works full-time. Full-time is all these people, and we don't count that 8 twice. So that's basically the problem. So all we need to do now is add those numbers, 7 plus 4 plus 35 plus 8 plus another 8. So we get 62 out of 100, that's 0.62. That will be this one. Alright, 23, 24, and 25. You are dealt 2 cards successfully without replacement from a shuffle deck of 52 cards. Find the probability that both cards are black. Well, there are half of the cards are black. I think half are black. So we have 52 cards. Half of 52 is 26. So we have 26 black cards. We need to find the probability that both of them are black. So the chances that the first card is black is 26 out of 52 times, because both its multiplication is the multiplication rule, the chances that the second card is black would be 25 out of 51. Right? So that's the answer. So we simplify this. Let me see how we can simplify this thing. So 26 divided by 52 is the same as 13. I think 52 is divided by 26. Agree? Yeah. And then right here we have 25 divided by 51. I don't see how this reduces to anything. This 13 divided by 26 is 1/2. So we got 25 over 51. So the numerator could be 25 and the denominator could be 102. Is there an answer like that? A. Anyways, the essence of the problem is right here. That you understand the multiplication. That you're saying you're drawing, you have 52 things. 26 have the characteristics that you want, but you want to drop, you want to get 2 of them. So the first one is going to be 26 out of 52, but you already took one of the color cards. Which one are you getting? Okay, one of the black cards. So then, because it's black and red only 2. So then 26 out of 52. So now 1 is taken out. So now it's 25 out of 51. And then right here, all this is reducing the expression. So the answer is A. We look at the next one. What is the probability that 4 randomly selected people all have different birthdays? Round your answer to 4 decimal places. So what is the probability that 4 randomly selected people all have different birthdays? Alright, so if we have 4 people, we need the first person so we can compare them. So basically what we need to do, the first person will have a birthday. So the probability that the first person that we ask, because we're going to ask 4 people, has a birthday is 1. Now, what is the probability that the second person has a different birthday than the first one? We know already, so this is conditional, we know already the first birthday. So the probability is going to be 364 out of 365 for the second person. Because if this person is born January 1st, there are 364 days where the birthday could be different. But now we have 2 days. So now for the third person, the probability that that birth is different than the first 2 persons is going to be 363 out of 365 days. And the next person is 362 out of 365. So that's the answer. If we do the mathematics here, we probably get the answer. The first person is fixed, it will have a birthday. Then the probability that the second person is different than the first one is 364 days left. Then 363, 663 days left. Let me see what this is equal to. Okay. Alright, so we got 364 times 363 times 362 equals. That's a huge number. Now we need to divide it by 365 three times. So divided by 365 and then divided by 365 and then divide that by 365 and we get 0.983 0.983 0.9836 0.98364. Okay, so that's that. So the last problem here, 25, says 25. The IRS auditor randomly selects 3 tax returns from 54 on which 15 contain errors. What is the probability that the selected none of the ones containing errors? Alright, need to make this problem a little bit. See, so this is a good question for assessment. So it says that the IRS randomly selects 3 tags out of 54, and the 54, which is the sample space, have 2 different characteristics, which is it has errors and it doesn't have errors. So if we select 3, what is the probability of selecting the ones that don't have errors? So what is going to happen right here, just to draw a picture, is the following. We start with 54, which is the possible tax forms 54, which are divided into 15 containing errors. So 15 errors, and the rest don't have errors, so it will be 39 of 54, yeah, 39, which is no errors, error free. Now we want to end up with 3. We're going to select 3 out of these 54. Now from the error ones, we want to choose 0 because the probability that none have errors. So the 3 will have to come from the ones that have no errors. Alright. And so in essence, what we have right here is a bunch of combinations. 54 combination 3 is the sample space. So 54 combination 3, it is the number of possible groups of 3 that I can make with 54. So I need a calculator. I need a combination calculator. Let me find one. Combination calculator. Alright, of course you're going to bring that one to the test. So there is one right here. So 54 combination 3 is 24804. 24804. So that's 24,804 different groups of 3 that I can make with these 54 forms. Now the other one is going to be what? I'm going to choose 3. So it's made up of 2 groups. 15 combination 0 times 39 combination 3. 15 combination 0 is 1, by the way, because I'm not choosing nothing from there. So if we go to my calculator again, where is it? And I put 15 combination 0. The 15 that are defective combination 0, that gives me 1. Okay, and then 39 combination 3, that gives me 9139. So this is 9139. 9139. So that is all these forms that have non-defective, all three are good. So your answer should be 9139 divided by 24804. My calculator, what is it? 9139 divided 24804 equals 0.3684. 0.3684. Okay, so that's 8. All right, let's continue doing this. So let's see. So we have a table, cross tabulation. If two different people are randomly selected from the 934, find the probability that they are both. So this is a multiplication, both women. So this is the probability of selecting the first female, which is 464 out of the 934, times the probability of selecting a second female. So now we reduce that by 1, so that will be 463, but the sample space is also reduced by 1, so this is 933. Alright, let's see if we get this answer. So this would be 464 times 463 divided by 934, and then we divide again by 933. So that would be 0.246, 0.246, 0.246. Probably that's the answer. Okay. So right here we have a table, and one of the 255 is selected. Find the is over 40. Find the probability that the person is over 40 years old. Over 40. So over 40. This is an easy problem. It's going to be all those people out of the 255. That will be 50, 75, 85. So 20 and 30, 50. And 85 out of 255. They've already as a decimal, so it can be reduced. So 85 divided by 5, that's 17. 5 times 7 is 35. Divided by 51. So this can be further reduced. 51 is divisible by 17. 17 3 times is 51. So this is 1 out of 3. I think the answer is A. Alright. Oh, no problem here. 28 says, again another table, we have 256, find the probability is over 40 and drinks cola. So this is over 40 and drinks cola. So that's an and. So you have to have both characteristics, over 40 and drinks cola. Only 20 people meet both characteristics. So that would be 20 out of 255. Alright, that's it. If we divide this by 5, we get 4. And we divide this by 5, we get 51. So that will be that answer. That's 28. That should be B. Alright, so the next problem is telling me that the following. Oh, let me see. Let's make this bigger. Cannot see that. Alright. So what is the following table contains? Again, we have a table. If one of the 87 flights is random by the probability that the flight selected arrive on time. This is very easy. Arrive number of flights which were on time. So arrive on time, we need all these flights. They all arrive on time. That will be 676. Out of how many flights? 87. So 76 over 87. 29, that would be B. This is too easy, so you do it. 5 permutation 4. That will be 5 factorial over 5 minus 4 factorial. So that will be 5 times 4 times 3 times 2 times 1, which is 2060, 120. Now in problem 31, 12 compete in a competition. If each wrestles one. Alright, so basically what we have right here is we have 10 things. Wrestler 1, wrestler 2, wrestler 3. So we have 12 of these people, alright? And they're going to do what? They're going to play each other, right? So basically we're making groups of 2, agree? These 2 and these 2. When W1 plays W2, that's the same as W2 playing W1. So this is a combination problem. This is just 12 combination 2. How many groups of 2 can I make with 12 people where order doesn't matter? So that's the answer. So let me go to my calculator that I found here, and if I put 12 combination 2, I should get the answer. 12 combination 2 66. Alright, and no, you cannot use the internet in the test. You definitely need to have a calculator that computes combinations, or you have to do it manually. 12 combination 6 is 12 factorial divided by 6 factorial, 12 minus 6 factorial. And then you deal with the factorials, and that's how you would get a 66 manually. Now, find the mean of the given probability. So I'm just going to set it up, you add it. So this will be 0 times 0.23 plus 1 times 0.2 plus 2 times 0.37 plus 3 times 0.06 and then 4 times 0.14. And let me do it real quick then. So clear. So that would be 0 times anything is 0, so forget about that one. 1 times the next one is 1 times 0.2, which is 0.2 plus 2 times 0.37 plus 3 times 0.06 plus 4 times 0.14 will give you 1.68. So that will be 1.68. Alright, a police department reports. Let me see what this is. A police department reports that the probability that 0, 1, 2, or 3 burglaries will be reported in a given day are. So what they're giving you is a probability distribution. The random variable is 0, 1, 2, and 3, the number of burglaries. And the probability of each is given. So this is a probability distribution, which is what? 0.45 for 1, 0.37 for 2, 0.17, and 0.01. These numbers are supposed to add up to 1. Let's hope they add up to 1. So then find the mean. Well, again, this is going to be 0 times 0.45 plus 1 times 0.37, 2 times 0.17, and then 3 times 0.01. This is 0, this is 0.37 plus 17 twice, this is 0.34, and this is plus 0.03. So this is 40.74. Should be 0.74 right here, because this is 0.37. That would be point, oh yeah, 0.4 plus 0.374. All right. So the last one, the probability that a batch of computers will contain 0.30 defective computers are blah 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 respect to run your answer to the integers. Okay, so that's the same thing. I am just going to set that one up. So in that problem, what you need to do is the probability distribution in number 34 is 0, 1, 2, 3, and 4, the number of defectives. And then the probability of 0, they're giving it to you, is 0.6561. The probability of 1 is 0.0486, 0.0036. Oh, I'm missing numbers here. 1, 2, 3, 4, 5. Okay, now they give you the 5 numbers. Shh, Alright. So that will be again, the 5 numbers are 0.65, 0.6561, 0.2916, 0.0486, 0.0036, and 0.0001. And so to find the mean number of defectives, you need to multiply these numbers. So this is going to be 0 times this is 0, 1, so you get 0.2916, then 2 times the number, 2 times the number, and you find the probability. So let me now compute this thing, because it's just too simple. All right. The number is the number of households. Find the probability is given. Find the mean. So again, this is just simple. All you need to do is to multiply 0 times 0.124, 1 times this, and then add it. Okay. We can even do this in the calculator without writing anything. So let's do it. So 0 times 0.24 is 0.24. 1 times 0.01, we can make 0.01. Plus, now I need to add 2 times 2 times 0.12 plus 3 times 0.16 plus 4 times 0.01 plus 5 times 0.14 plus 6 times 0.11 plus 7 times 0.21, 3.6. Okay, I ran out of problems. Okay, well, I'm not sure if there are more problems, but cannot find any more. So I think this is the only one problem left. So it says that the prizes that can be won in a lottery are listed. You can win 3,500. You can win $14,000. Oh my goodness. You can win 600, 200. Find the expected value. Okay, so the expected value right here of the amount of one entry if the cost of the entry is 55 cents. So basically the sample space right here is win or no win. So that's it. So what happens? Let's do a probability distribution. Okay, probability distribution. What are the possible values of the earnings? It's going to be 3,500, but it happens very rarely. 1 in 8800. You get 1400. How many in what chances? 1 in 6300. You can get 600 in 1 in 3,000 chances, or you can get 200 in 1 in 2900 chances, and then you can lose 55 cents, minus 55 cents, the rest of the chances. So what we need to do is calculate each one of these numbers, and then this will be 1 minus all these numbers. All right. So let me see. So the probability that you will win the 3,500 is 1 divided by 8800, which is, that's a small number. Oh, maybe we'll leave it like that. Okay, so that's it. And this will be 1 minus 2. So this is P of X. Alright, so now the expected value, or the mean earnings right here, here's a number, the mean is going to be 3,500 divided by this 88, 1 times that number, so 8800 plus 1,400 divided, because the probability is 1 times this when I multiply it, times 6300, plus 1,000, okay, 600 divided by that number, plus the 200 divided by the 2900, minus the 55 divided by the number that we haven't found, which is all these probabilities minus 1. All right. So whatever number goes in there, you subtract it, and then that will be your answer. But since I have to go, I let you make those computations. So I hope that you understand. These probabilities add up to 1, so you need to say 1 minus this. See if we can do that in the calculator. 1 minus, let's open parentheses, what are 1 minus 1 divided by 8800, close parentheses, minus 1 divided by 6300, minus 1 divided, oh shoot, I multiply. Okay, let me not do this computation right now. I have to go. Thank you for listening to this section, but make sure that you finish this problem. All right.